Welcome to your favorite episode of the 5G Tech Talk. It is a calm and peaceful Sunday morning. Once again, I would like to thank you for giving the amazing response to this podcast series, where we explore and break down the future of connectivity and its real world applications. We are here to break down the core concepts and fundamentals of the topic in a simple and easy way. And today, we are diving into cutting edge topic of 5G technology, that is edge computing. If you have heard the term but are not quite sure what it means or how it works, stick with this podcast. We will be exploring what edge computing is, how it operates, and real life use cases that are transforming industries. So let's get started. So what exactly is edge computing? Simply put, edge computing allows user equipment or mobile to access services hosted close to the serving base station. In plain terms, instead of sending data to a centralized cloud server that could be located hundreds or even thousands of miles away, edge computing brings those services closer to where they are actually needed. Now, why is this important? Let's break it down. Edge computing offers two significant benefits: improve end user experience and enhance network efficiency. First, let's talk about end user experience. Since the services are hosted near the base station, user experience much lower latency, meaning less delay between sending a request and receiving a response. Whether you are streaming a video, using an app, or working on a corporate network, this results in smoother and faster service. And that's the way we achieve the latency in the count of milliseconds. Now, on the network side of things, edge computing reduces the need of transferring heavy data across the network. Traditional setups, a lot of data has to travel to and from the core network, which can lead to congestion. By keeping more of that data closer to the user, edge computing reduces the amount of traffic that need to go back and forth, making the network run more efficiently. Think of it like this: instead of sending your data across a long highway to reach a central data center, we are setting up services closer to home. In that case, the nearest base station. This proximity allows faster access and improved performance. So, how exactly does edge computing work? Hosting services close to the base station involves placing the right component in the right place, like the user plane function or UPF and a local area data network or LADN at a geographically close to base station. This could mean co-locating them with the base station or perhaps with a router in the transport network. Alternatively, they might be located at a regional data center. The key point is that they are always close enough to serve the end user without causing unnecessary delays. Now, to connect to the local area data network, LAN, or a PDU station would be established. A PDU station is nothing but similar to the EPS bearer in 4G. This PDU station in 5G provides end-to-end user plane connectivity between the user and the data network. Notably, a single PDU station can access both local and remote data network, making it highly versatile. So, this is some technical aspect of edge computing. But to give you a clearer picture, let's dive into some real-world example of how edge computing is being used. Imagine you are at a major sporting event like a Formula 1 Grand Prix. You are sitting in the stand, but from your location you can only see a small section of the track. Wouldn't it be great to watch the rest of the action in real time on your device? With edge computing, you can. Video streaming services can be deployed right at the venue, allowing spectators to choose specific drivers and follow their progress through a local video stream. Edge computing can enhance your experience by delivering real-time video streams. You could choose to follow a specific driver, and a video stream from different part of the track would be generated and distributed locally thanks to edge computing. The video content is processed and accessed right there at the venue. The UPF, user plane function, and LED, local area data network, could even be co-located with the centralized unit of the base station serving that venue. This setup means that the video content is generated, distributed, and accessed locally. It is fast, localized, and make your viewing experience far more immersive and seamless. Example 2. Let's talk about augmented reality. Think of a museum using augmented reality to give visitors additional information as they walk through different exhibits. With edge computing, a local server could run an app that tracks your location and provide information relevant to where you are. It is like having a personal guide, but the data is not traveling to some distant cloud. It is happening right there at the museum, giving you real-time interactive experience without delays. Edge computing also shines in corporate environment. Let's say a large office that is own corporate network, defined as an LADN. By connecting this to a UPF type co-located with a base station, employees can access their network locally without having to send data all the way back to the core network. This improves speed, security, and efficiency for day-to-day business operations. And finally, another exciting example is vehicle to infrastructure communication, or V2I. Imagine you are driving along a highway where roadside units or RSU are positioned. This unit communicates directly with your vehicle, sending important data like traffic signal timing or available parking spaces. Edge computing makes this possible by ensuring that the RSUs, which are aware of nearby traffic signal timing, can instantly send that information to vehicles. This ensures vehicle can adjust their speed in real time to avoid stopping unnecessary at traffic lights. So in summary, edge computing is all about bringing services closer to where they are needed, improving both end user experience and network efficiency. By hosting services near the base station, we reduce latencies in backhaul data transfer requirement. And with applications ranging from sports streaming to smart traffic system, edge computing is truly revolutionizing how we interact with technology today. Thanks for tuning in to today's episode of 5G Tech Talk. I hope this gives you a clearer understanding of how edge computing is enhancing our digital lives. If you enjoyed the episode, don't forget to subscribe for more insight into the future of technology. I'm Modi Darani signing off. We'll catch you next time again with a new topic. Thank you.